All right, so I was asked a question about trying to help out with the following problem. It says, let f of x be a twice differentiable function. Now remember, f of x being twice differentiable, this part right here, means that you can take the derivative of it twice. Okay, and that'll come in a little bit later as to why that's mentioned. But let f of x be a twice differentiable function such that f of 1 equals 3. Now remember, f of 1 equal to 3 is called an initial condition. Okay, so it's something that they're giving us. They're telling us this is important. So make sure you're aware of that. They say, and we also know that the first derivative of this function f of x is 4 radical y squared plus 7x squared. And they say, what is the second derivative? Now notice they want us to figure out the second derivative, and they told us it was twice differentiable. In other words, they know that you can take a derivative of this first derivative to get a second derivative. So they're just trying to let you know, like, look, it's okay. We know that you can take two derivatives of the following, so feel free to do that. All right, so here you go. So we start off with dy dx equal to 4, and instead of the square root, I'm going to put y squared plus 7x squared to the half. Now I'm going to start taking the second derivative, so d squared y dx squared. I think I just realized that I wrote this problem wrong up here. Sorry about that. Let me fix that. d squared y dx squared. So anyway, so second derivative. So the 4 is just a constant that multiplies the function. So I'm just going to use the constant multiple rule. That means I pull it out, okay? Now I'm going to have to take the derivative of y squared plus 7x squared to the half power. Now you'll notice this is a chain rule because there's an inside portion with a power on the outside. So I'm going to have to do this using a chain rule. So we bring down the power first. That's a 1/2. Then rewrite what's inside, y squared plus 7x squared to the negative half. And then we have to take a derivative of the inside portion. Now you got to be careful here because notice we're going to take derivatives of x's and y's, and I'm supposed to be taking derivatives with respect to x. So the first one is y squared, so that's a 2y. But I need to do dy dx because that's the wrong variable, so I got to mention it. I took a derivative of y when it should have been an x. And then 7x squared becomes 14x, and you don't have to put dx. So there it is. Okay, there's my problem. Now here, let's see, if we try to simplify this a little bit, let me get rid of this here. So if we try to simplify this a little bit, the 4 times the half, when you bring this in, is going to become a 2. This whole bottom part right here is going to be a square root of y squared plus 7x squared. And then the top part, we're going to get 2y dy dx plus 14x. Okay, now I know that doesn't look very nice, but that is what the derivative is. Now, they want us to plug in a 1 for x. Now, notice, if x equals 1, then we got to figure out, well, what's y? Well, I'm going to put it right here. If x equals 1, then y equals, well, we should know that. It's equal to 3. Why? I'm going to put since f of 1 equals 3. So we know that if x equals 1, y equals 3. So d squared y dx squared when x comma y equals 1 comma 3 is, so 1, 3. So 2 times 3, right? So 2 times 3. Right now we'll do the dy dx part. Plus 14 times 1. And then we're going to divide all of this stuff by the square root of y squared. So that's 9 plus 7 times x squared. That's 7 times 1. So it's just 7. Okay. So what is dy dx? Okay, this part right here, that's going to go in there. Okay, so let's figure out dy dx when x and y are 1 and 3. So I'm going to do a little bit of work up here. So dy dx when x and y are 1 and 3 equals to, so let's see, dy dx. They told me dy dx is 4 y squared plus 7x squared to the half. So 4 times 9 plus 7 to the half. Now 9 plus 7 is 16. So it's 4 times 16 to the half, which is 4 times 4, which is 16. So that goes right here. Okay, that goes right there in that little space. So now all we have to do is just combine everything. So 2 times, let's see, 2 times 3, that's 6 times 16 plus 14 over, the bottom is squared is 16, so that's just going to be a 4. Okay, so let's see, we'll reduce 6 times 16 plus 14 over 2, because the 2 and the 4 will reduce. Then I can further reduce by 2, so this will be 3 times 16 plus 7, because I'm just dividing 2 of those terms up there by 2. So 3 times 16, that's 48 plus 7, so that's going to be a total of 55. So there is your solution for the second derivative of that function when x equals to 1.